Reactions that form water. So we talked about reactions that form a solid. Forming a solid was a driving force for reactions. There are other reactions that form water, and these are acid-base reactions. So we learned about acids in terms of naming them, but acids also have some chemical characteristics or chemical properties. So a strong acid is one in which virtually every molecule dissociates or ionizes to form hydrogen ions and an anion. And so HCl, we've learned to recognize that as an acid. When you put HCl in water, it ionizes, it forms ions. HCl is not an ionic compound, but when you put it in water, it forms ions. It's kind of a subtle distinction there. HCl in water dissociates almost completely. You're not going to find any HCl molecules. The same thing goes for nitric acid and sulfuric acid. They're going to ionize. Now, sulfuric acid has 2 hydrogen ions, and so it can lose one or both of them. It'll lose one first. Nitric acid has 1 hydrogen. It's going to lose that, and you're going to have a hydrogen ion and a nitrate ion. That's a strong acid. Here's an illustration. So HCl, pure HCl is a gas. If we dissolve that in water, it forms ions. I'm not sure what else to say about that. A strong acid behaves like a strong electrolyte. So, yeah, it is what it is. And then we have strong bases. Strong bases are just soluble metal hydroxides. So it's a metal hydroxide that's completely soluble in water. So there aren't very many of them because most hydroxides are insoluble. The 2 most common ones are sodium hydroxide and potassium hydroxide. They are completely soluble in water, so you put them in water and you get ions. You get potassium ions and hydroxide ions. From potassium hydroxide, you get sodium and hydroxide from sodium hydroxide. They dissolve, they ionize. A strong base is also a strong electrolyte. Now, if you mix an acid with a base, you get very predictable products. The products are going to be water and salt. And salt in chemistry land means any ionic compound, not just table salt, sodium chloride. So you mix an acid and a base, you're going to get water and a salt. The net ionic equation for these acid-base reactions is always going to be the same, which is pretty cool. It's the hydrogen ion from the acid, the hydroxide ion from the base, and they're going to get together and form water. And so when we have a reaction like this, we call it an acid-base reaction because we have a reaction between an acid and a base. So the H plus is the acidic ion that comes from the acid. The hydroxide is the basic ion, and it comes from the base. So here's a summary. Common strong acids are aqueous solutions of HCl, HNO3, and H2SO4. Strong acid dissociates in water and ionizes completely. A strong base is a metal hydroxide compound that is very soluble, so it also dissociates into hydroxide ions and cations. The net ionic equation for the reaction of a strong acid and a strong base is always the same. It's hydrogen ion plus hydroxide ion, and it produces water. The other product besides water is an ionic compound that's called a salt, and that generally remains dissolved in the water. But you could get that out, you could get that back by letting all the water evaporate, and you'd have the salt left. We call these acid-base reactions. So if we have HNO3 and LiOH, what's the net ionic equation? Well, let's look at this for a minute. I mean, we could just do the whole thing, or we could look at it. Okay, so HNO3, that's an acid, right? And LiOH, that's a base. So this is an acid-base reaction, and they're asking us what's the net ionic equation. The net ionic equation for an acid-base reaction is always the same. What is it? C. So that's the acid-base net ionic equation. So just for grins, let's actually do that and prove it to ourselves. So our reactants here are nitric acid, which is aqueous, and lithium hydroxide, which is also aqueous. And they're going to react to form something. So what we're going to do is we're going to have these guys swap partners, because we know that the acid makes ions in solution. So nitric acid dissociates into hydrogen and nitrate ions. And this lithium hydroxide is a soluble ionic compound, and that dissociates into lithium and hydroxide ions. And so then the question is, what happens to these guys? Well, the lithium and the nitrate are going to partner up, and the hydrogen ion and the hydroxide ion are going to partner up. Well, lithium and nitrate together, we have to decide, is that going to be soluble? And if we look in the rules, yeah, it is, because lithium compounds are soluble and nitrate compounds are soluble. So lithium and nitrate are not going to go off and find a couch somewhere. What about H plus and OH minus? Well, if we just treat those as ions, what would they make? We've got plus 1, minus 1. We would just push them together, right? And that looks kind of weird. What if we wrote the two hydrogens together? Oh, that's water. Is water soluble in water? Does it dissolve? It is water, right? What is the physical state of water at room temperature? It's a liquid. So there we've just kind of pieced out the total ionic equation. The lithium ions are going to be spectators, because lithium ions with hydroxide ions were soluble, and lithium and nitrate is also a soluble compound. So they're going to stay dissolved and stay as ions. And the nitrate also. So if we cross those guys off, the nitrate doesn't change, the lithium doesn't change, then we end up with this guy right here. So that happens with all the reactions between strong acids and strong bases. Because the strong acid always has hydrogen ions, the strong base has hydroxide ions, and the other ions really don't matter. They're just in the audience.